Lesson time, yes. Happy. Lesson time is here yet again. Module 6, Lesson 12, digging deeper into decimals. Well, if you didn't like the comparison of decimals thing, although we'll do a slight review of that today, I have good news for you today, because here's what we're doing. Bing! We are going to take what you know about fractions and equivalent fractions, and we're going to use it simply to do what? Well, here's our key word. Add. We will be adding decimals today, tenths and hundredths. And how we're going to do that, we're going to take what you know about equivalent fractions. For example, that 1/10 equals 10 hundredths. So if you're strong on that, you will find today pretty straightforward. Let's start off with a little fun though, shall we? There we go. We're going to add and subtract, and here I will need you to pause the video and go ahead and do this, and then come back and check your answer. But first we're going to start off adding. We're going to write it in standard form. It's here in unit form. 473,379 ones plus the same. Okay, and what would that look like? Yes, all right. And go ahead and add. All right, did you get 946,758? If so, then perhaps one of us is correct. I don't know. I hope it's me. I'm supposed to be right, at least some of the time, right? Here we go. 384,917 ones plus the same. Go ahead, write that out in standard form. Should look like that. And go ahead and do the addition. And did you get 769,834? I hope so. All right. How about here? Another addition, 700,110 plus 199,856 ones. Well, so far it's been easy because, like, just looking at this, it's 199,856, right? But here you have to do a little more thinking. 700,000. Okay, we could do that. 110. No, what's going in the hundreds place? Give me a clue. Yes, we will have a 0 there. So this one is set up like this. And boy, aren't you glad we're adding and not subtracting, because subtracting across zeros can be a little bit of work there, right? All right, so go ahead and add those up. And did you get 899,866? Yeah, and you probably got that a little quickly even, because was there any regrouping there? Not a one. Guess what? I got a treat for you. Yeah, now subtract those same numbers. And when you are done with all that heavy-duty regrouping, you should have 500,154. Great. Okay, let's see. Now another one. Let's do another one now with lots of zeros to subtract across. 900,000, 8 tens, so a similarly formatted number, minus 500,000, 154 ones. So writing that out from unit form into standard form would look like that. And then you have lots of zeros to regroup across. Got that? Okay. Did you get 399,926? Goody. All right. And by the way, on all these, you could do a pretty quick and easy rough estimation by just saying, hey, 9 minus 5 is 4. My answer is around 400,000. This makes sense. Great. Now let's do as promised and compare some decimals. We already did this, so I'm going to kind of cruise through this. If you need to, go back to the previous lesson. 3 and 20 hundredths compared to 3 and 2 tenths. Now we know, of course, if we convert this to hundredths, they are identical. Yes, indeed they are. So equals, beautiful equal sign. 7 and 8 tenths compared to 7 and 85 hundredths. All right, again, convert this to hundredths. Yeah, so that would be 7 and 80 hundredths compared to 7 and 85 hundredths. 80 being, that's right, less than 85. Wonderful. How about this? How do you like these apples? 5 and 72 hundredths compared to 5 and 27 hundredths. Very good. Yeah, these ones are pretty straightforward. They have the same whole number. They give you the same digits, thinking maybe that'll confuse you, but no, you're not confused. 72 is more than 27, greater than. Excellent. 2 and 9/10 compared to 2 and 89/100. And this would be, what would be the mistake to make here? That's right. It's good to identify what the tendency to error is, because then you're more likely to catch yourself when you do that. To say 9 is less than 89, therefore this is less than, would be the error, right? But we know that 9/10 is 90/100, which is just a slim hundredth more than 89/100. So this is actually greater. You see that now? Great. Wonderful. How about this one? Same as that last one we had with 5 and 72. Same digits, scrambled a little bit. 6 and 24/100 compared to 6 and 42/100. 24 being, yes, less than 42. Excellent. 10 and 8/10 compared to 10 and 8/100. Well, this is a good one, especially to think about in terms of money. Of course, we convert this to hundredths, imagining that 0 there. 80/100, 8/100. Ah, yes, $10.80 would be a lot more than $10.08. 8 dimes is more than 8 pennies, for sure. So this is greater than. The tendency to error here might be to say, oh, this number's longer. It has more digits, therefore it's more. So that would be an error. Very good. All right, 14 and 39/100 compared to 14 and 9/10. Excellent. So what would be the error here? You had to say 9 is less than 39, of course. But let's look at this. 9/10 is how many hundredths? 90/100. Yes, so 39 is less than 90. So this is a big bad less than. Beautiful. Now we're going to put these in order from least to greatest. All right, let's just do this together. Let's look at this. We have, what's this number? 3/10, 1/10, and 44/100. Well, where do you think is a good place to start? Well, I noticed, and perhaps you noticed with me, that 3/10 and 1/10, when we say them especially, even though it's in decimal or fraction form, when we say them, there's a pretty straightforward comparison there, right? 3/10 is more than 1/10. Very good. Okay, so from least to greatest we're doing, so 1/10 would come before 3/10. And then we have 44/100. There's a couple ways of thinking about this. If we say this is, the 3/10 is how many hundredths? 30/100. 44/100 would be more. So our least is the 1/10, then comes the 3/10, and then the 44/100. How do you like them apples? You love them. Green apples. Moving on. Oh, 7 terms to put in order. I warned you. But guess what? You know how to do this. All right. 13/10. Well, how would we write that in a decimal form? Let's put all these into decimal form, make it a little easier to make the comparison. 13/10 would be written as, well, 10/10 is 1, right? And that leaves 3/10. So 1 and 3/10. As a decimal, we write 1.3. Very good. 43/100. How do we write that as a decimal? 43, such that it ends in the hundredths place, so 0.43. 100th, we write a 1 in the hundredths place. Excellent. This, already in decimal form to the hundredths place. This one we can take out to the hundredths place, right? Okay, how would that look? Right, 0.10 is how would you write 1/10 instead as 10 hundredths. 55/100, already decimal form to hundredths place. 66/100, already to decimal form. Now we want to go again least to greatest, and now think of money, and on this one here, I didn't put it there, but imagine, yes, converting that to hundredths, that we'd have a 0 here. And notice, what do you notice about the 1 and 3/10, which we could also call 1 and 30/100? It's the only one, yes, that's greater than 1. All of these have a 0 in the ones place. So the 1 and 3/10 is definitely the greatest one. It's the only one that's greater than 1. Okay, so we already put that one away. Now let's look for the least. And think of these in terms of money as well. Yeah, 1/10 is just a penny, right? That would come first. Then what? 10 cents, right? 10 hundredths, then 43. See, I told you once you get to this point, it picks up speed, doesn't it? 54, 55, 66. We already said the greatest was that one. And there they are. Isn't it beautiful? Ah, moving on. Here we go. We're going to take what we learned and apply it. That's what application problem means. Did you know that? It's not like you're applying for a job, like you're filling out an application, which you can do if you want. But what you're doing is you're applying what you learned. So on Monday, 1 7/8 inches of rain fell. Tuesday, it rained 1/4 inch. What was the total rainfall for the 2 days? Well, now let's think about this for a moment. Total rainfall for Monday and Tuesday. Okay, so we're putting together. So we'll draw one tape, right? Because we're putting together. We're not comparing. Remember, we do separate tapes when we're comparing, but here we're putting together, so one tape will do it. Could we draw two separate tapes and then join them with a bracket? Sure. Easier to draw one. Notice, though, that we have this 1/4 of an inch, and we have these 1/8 inch. Ah, yes, those are different denominators. So let's resolve that little problem right now. And I'll do out the math for you in a moment, but let's do it mentally now so you can imagine it. 1/4, let's convert that to eighths. What would we multiply by? 4 times what is 8? 2. So 1/4 we're going to multiply not by 2, but by 2 halves. Remember all of this from fraction land? Some modules ago, yay, so long ago. Okay, so that would be how many eighths? 2/8. So I'd like to, and the reason I did that up front, so when you go to draw your tape diagram, we know total rainfall is what we're trying to find. We have 1/7/8, and then with that 1/4 inch, you see already I've said, hey, it's an eighth and an eighth. And that will help us quite a bit. So here's what it will look like in mathematics. Total rainfall is Monday plus Tuesday, 1/7/8 inch plus 1/4 inch. Well, what is that going to look like? The 1/4 is an eighth and an eighth. We can join together here. Look at that. What do we need to complete 1 7/8 to get to the next whole number? Oh, one of these eighths. So that'll give us 2 whole inches with what left over? 1/8. And here's the mathematical way, by the way, of doing that conversion of fourths to eighths. This is what we said. Times 2 halves is 2/8. So in case you're wondering, where'd you get these 1/8, 1/8 from? That's why I put that here, so you can see that's where that's coming from. All right, so now we add them together. We get 2 inches and an 1/8 inch, total of 2 1/8 inches. And then, yes, I was waiting for you to say, what do we need to finish this out? Yeah, we need a statement there. The total rainfall for the 2 days was 2 1/8 inches. Hot dog and hallelujah. Moving on. Now we're getting to it. We're going to add tenths and hundredths. How are we going to do it? Well, pictorial models is what you're going to do in a problem set, but I left it off here so you can see what we're doing mathematically. So, in unit form, 3/10 and 4/10 is, 7/10, right? And so this, I show you that so you see where the extra step comes in. Because this is, right, you can do that. Yeah, 3 and 4 is 7. Okay. But then if we had 3/10 and 4, hundredths. Well, that's a different dog now, isn't it? We can't just say it's 7 anything or whatever. We have to think about it a little bit at least. We have to make like units. We have tenths and hundredths. Which one are we going to convert? Exactly. The tenths we can convert to hundredths. We can rename it 3/10 as 30 hundredths. Now we're adding 30 hundredths and 4 hundredths. What's that? 34 hundredths. Excellent. You see, good. All right, now this one introduces something else. Instead of having a single digit number here in both cases, we have a 2-digit number. Still with no regrouping though. 2/10 and 17 hundredths. Well, come on. 2/10 is what? Okay, how many hundredths? 20 hundredths. You're getting the hang of this, aren't you? Put them together, 37 hundredths. How do we write that as a decimal now? 0.37. Excellente. Now you could, I bet you say, we don't have any regrouping yet, but same idea. That what they do? Right, they put the tenths second. It doesn't matter because addition is, yes, commutative. 36 hundredths and 6/10. 6/10 is how many hundredths? It is 60 hundredths. Excellent. Put them together. 96 hundredths. Excellent. As a decimal, 0.96. Got it. Now, after doing it that way, we're going to convert them using multiplication and express the sum as a decimal. In order to, again, what's the key word for this whole lesson is we are adding. We're adding decimals. All right. So now here it is in fraction form. Same idea as we were just doing. 3/10 and 13 hundredths. Well, what do we do with 3/10 to make it hundredths? You remember this from equivalent fractions, just like we said at the outset. 3/10 times 10/10 will give us hundredths. How many hundredths? Very good, 30 hundredths. Now we can add 30 hundredths and 13 hundredths and get 43 hundredths. As a decimal now, 0.43. And so part of the idea here is that if you were giving 0.3 plus 0.13, in other words, if you were given this in decimal form, you could rewrite it in fractional form quite easily, and then do the conversion in fraction form, which you may find easier to do, and add them that way. You could also use this as an alternative method to check your work. Beauteous. Let's move on. 2/10 and 36 hundredths. Yes, you see. What are we doing to 2/10? Okay, here on the side, times 10/10 will give us how many hundredths? 20 hundredths. So now we can add 20 hundredths, 36 hundredths, total of 56 hundredths. You're getting good at this. As a decimal, 0.56. Excelente. 40 hundredths plus 6/10. All right, notice they did the same thing. Move the tenths to the second place, but it doesn't matter because addition is, I just said it, commutative. Very good. 6/10 times 10/10 will give us hundredths. How many hundredths? 60 hundredths. Great. So now we can rewrite this, put them together. What do we get? Oh, something different. 100 hundredths. Notice that everything we've done so far, the sum has been less than 1. It's always been 0 point something. This is our first one that is exactly, that's right, 1, which we would write, as a matter of precision, as 1.00 because it is 100 hundredths. And now that leads us right into the last little piece of the puzzle here, which is doing the same thing but with sums that are greater than 1. So we've only gone up to 1 now. We're going to go greater than 1. So you think this is going to be entirely different? And no, it's going to be the same thing, except you might have some regrouping. You have greater than 1. Let's do it. Here's an example. 6/10 plus 57 hundredths. 6/10 is how many hundredths? 60 hundredths. Now we can add the 57. A way to do this in your head, by the way, similar to something we did last time, is to mentally take, what do I need to make 60 complete, the 1 whole? 40 bring it over, right? You see that? And what does that leave? It leaves 17. So 60 and 40 hundredths gives us 100 hundredths, or 1 whole, and 17 hundredths, 1 and 17 hundredths. As a decimal, 1 and 17 hundredths, 1.17. Great, that's how we'll do these, okay? This is a great way to do mental math, and I tell you a little secret. This is how I actually do math like this in my head. It's true. Okay, 9/10 and 64 hundredths. 9/10 as hundredths is 90 hundredths plus 64 tenths. Okay, what do we need to the 90? We need to swoop over 10 hundredths there. What does that leave from the 64? 54. There's our nice juicy 1 whole, right? With 54 hundredths. So 1 and 54 hundredths as a decimal, 1.54. Lovely. How about these apples? 2/10 plus 91 hundredths. Okay, 2/10 is 20 hundredths plus 91 hundredths. What do we need to complete the whole here? Yes, we need to swoop over, or decompose is our mathematical term, right? We need to decompose the 91 hundredths and pull out 80 hundredths to give us our 1 whole there, leaving 11 hundredths. There's our 1 whole, so it's 1 and 11 hundredths. As a decimal, 1.11. 1.11. 8/10 plus 45 hundredths. 8 tenths is how many hundredths? 80 hundredths and 45 hundredths. What do we need to complete the whole here? We need 20 broken off that 45, which leaves 25. 80 and 20 make our one whole, 100 hundredths, right? So 1 and 25 hundredths, expressed as a decimal, 1.25. Beauteous! Whoa, look what you did! Oh, you got to the problem set. Okay, so this is the same thing we were doing at the beginning, except that I left off doing the place value chart because I didn't want to make this too onerous for you. But here you see we did this before. Yes, we did. We did this. I can't remember which lesson it was, but we did this. We take the tenth, decompose it as 10 hundredths. And so that's all you have to do here. And look how nice they were. All the digits are 2 and 1. So you won't have a whole lot of dots to draw to decompose. It's not like you're taking 9 tenths and drawing 90 hundredths. Ha! I'd go on strike. All right. And then same thing here, except without the place value chart, just going in unit form. Okay? So you're going to take that 1/10 here, for example. How many hundredths is 1/10? 1/10 is 10 hundredths, right? Plus 3 hundredths is, there you go. That's how you do those. Here, same thing, but you're starting in fractional form. 2 tenths. Convert the tenths to hundredths. So that would be, right, 20 hundredths plus 8 hundredths. You got it. That's how you do those. Same thing here, but what's going on? You can probably see, you're right, these are the ones that will be greater than 1. And note, in both cases, back on number 3 and here on number 4, you will find a mixed number or a fraction as your immediate answer, and in both cases, in 3 and 4, write your final answer as a decimal. So if it was 1 and 28 hundredths, you would write 1.28, for example. This is one of those late night, I call these the late night word problems, when the poor people who made Eureka Math, God bless them, were up late and they were just all out of creativity and they're like, oh, I have to write a word problem for lesson 12. And so they're just, things just like suck dry of any creativity, but we will answer it faithfully nonetheless. We have beaker A and beaker B. And notice they use the passive voice. It is filled. By whom? We don't know. It's just you got 2 beakers that are magically filling up. So the question is, if you empty them both into the larger beaker, how much would it contain? Yeah, what's the operation there? Yeah, it's addition, you can tell from reading, and also because, yeah, this is a lesson on adding decimals. Okay. And then you get the exit ticket, which is more of the same, but shorter, simpler. And then, yes, homework. And if you're doing the homework, hop over to Homework Time, that video, to do that question by question with me. Well, look at what you have done now. You have completed another Eureka Math lesson. Kudos to you. Bravo, bravo. And I will see you next time. It is, once again, lesson time.